Hello statistics student. In this video, we are going to cover 2.5 and 2.6. We're going to look at how we can use measure of center to distinguish skewness of a center. So what is center of a data? A measure of a center of a data is the middle of the data set, or actually when we say middle, is the most typical, most representative values that summarize the data. Like it is, if there is another data that you are to predict, you would say it probably is that center. So most of the time it's in the middle. It could be the median. It could be the average, right? So these are the two common ones. And actually in this particular book, they have four measure of center that we can use. Now, all of them are good measure of center. A lot of time they are the same, but sometimes they're not the same, and then they have different properties. So in this video, we're going to cover which one is a better one, and what situation is it a better one. So the first is mean, second is median, the third is mode, the last is called mid-range. Mean in layman's term or in a non-statistic term is just called the average. So in daily life, when we say, oh, that the average is something, they actually call it is actually referring to the mean. And sometimes in mathematics, we call it the arithmetic mean. So mean is the average. That means you add all the numbers together and divide it by the number of data that you have. And in a statistical formula, we use this notation, sigma x over n. Sigma means add all of these together. So it's a sum. That means a sum. N is sample size, how large the sample is. So this is a very common symbol that people use for sample size of a sample that you collect. There is another formula, or actually it's not another formula, but there is another symbol for mean. It's called mu. Now, mu is a Greek letter, Greek letter, some Greek letter that you might know is like alpha, omega. You might have heard about those. But for statistics, we use quite a number of Greek letter. So the sample mean is called X bar. X bar, they have the same formula because it is just representing an average. So you add the data divided by m, the number of data. But in terms of the formula, they look a little different. If you are looking at calculating a population mean, that means all these data values are everything in your population. Presumably, if you have a small population that you want to study, it's possible to collect all the data. The government is doing a census. They can have all the data, right? And the big capital N is representing the population size. So again, in terms of formula, they are actually exactly the same, but we call them differently. If your data values are from a sample size, from a sample, you divide by small n, which is the sample size, and the value that you calculate is called X bar, is sample mean. If you have all this population data, the data value that you add together and divide by n is also a mean, but is symbol as mu. And it read as and that's how you write it. The way you write it is almost like a U, but I'm not a Greek letter person, but you can see that you write the first stroke longer, and then like that. Okay, it's read as mu. So if you see these letters, you know that the data values are population or mu. And of course, if we have a sample mean, we wanted to use sample mean to estimate population mean. That means we use X bar, which is a statistics calculated from a sample, to estimate mu. So we don't know what mu is. Sometimes we cannot have all the population, but we really want to use it to estimate. Now, can we actually estimate it? What are the important things that we can use to estimate it. Of course, your sample must be a representative sample. It must be big enough. It must be a random sample, right? It cannot be a voluntary sample, etc., etc. So the same thing that we talk about in chapter 1. So some properties of mean. So when we talk about mean, it's in general both sample mean and population mean. The good thing is it uses every data values, but this is one thing that is you can say it is a disadvantage of mean. Is extreme value can change the value of mean, can affect it. And in statistics, we have this term called resistant. Mean is not resistant. If there is an extreme value, extremely low or extremely high, your mean will change a lot. So let's do an example. Now, to calculate mean, of course, if I have a very small number of data, I can just use a scientific calculator and add them together and divide it by how many do I have? 1, 2, 3, 4, 5, 6, and you can just do that. But later on, when we have larger number of data, we do not want to enter the data one by one in a scientific calculator. So I'm going to show you how to calculate mean. So this is the data that I have. So if your data is recorded in an Excel file, this is an Excel file, you highlight it and you copy it. Don't copy the title, just copy the data set. And then you go to StatDis. Okay, so this is StatDis. I'm going to clear all the stuff that I have. So you will go back here. I'm going to move it a little better so you can see it a little better. So this is StatDis. Your sample editor should show up. If not, you just click on Show Sample Editor, and then you do not paste, but Control V. You have to use Control V to paste it, then it will paste in a column. So after you put it in the editor, that means your data is saved. You can use it multiple times. You can have different sets of data. So it's better than managing it in a scientific calculator. And then you go to Data, Explore Data, Descriptive Statistics. 1. So your data is in the column 1. So you say, calculate column 1 for me. So that is 80. Mean is 80.3. Go back here is 80.3, right? So we write down 80.3. But let's pretend that we have one big data that we, or one extreme data that we encounter, that we inserted. For some reason, when I collect this sample, I have a data that is really low, 5. Okay, 5. So we'll just evaluate it again. You can see that the mean now becomes 69.5. So in the past, before this 5 is here, 80.3 is kind of like the middle or very representative of the data value. But once you add 5, the average becomes 69.6. So most of our data is not 60, right? All of these 78, 89, 75, 82, they are in the 80, 70, 90, but only 2 data are in the low end, but the mean become very low. So you can see this effect. Mean is not resistant. If you have a very small value, it becomes very small. If you have a big value, it becomes very big. So if your data has extreme value, it does not represent the population very well. So it affects it. The second one is about representing mean of the whole class. So say, for example, I want to pick 5 scores, and I want to see if it can represent the class mean. So the 5 scores I pick would be the top 5 score. When I calculate this, 90, 95, 92, 98, 89, let's put it in. I don't think I have it. 90, 90, 95, what is it? 92 to 89. Yeah, so you can also manually enter your data, 89. So we have this data, and then we say, okay, I'm going to evaluate here. Evaluate column 2. The mean is 91. So this mean, oh, really? Did I calculate it wrong? 90, 95, 92. Oh, I calculated wrong. It should be 98, not 89. So calculate again. Oh, okay. So see how it is good to have this editor. 92.8. So can I say that, oh, the whole class is 92.8 mean? No, because this is top 5. It is not a random selection, so you cannot use it to estimate the whole class. Maybe the first mean is a good representation. Okay, so that's how you do mean, and that's a property of mean. The second is median. Median is the middle data, is really the data that is in the middle. So the way we calculate it is the same. You do statistics, calculate, put the data in, and in descriptive statistic, in addition to mean, they have median, mid-range, all show up here. So the first 3 are the measure of center. Okay, so you would just say, just do the descriptive statistics under statistics again. So how to, if you want to calculate by hand, this is what you do. You arrange them in order. If it's an odd number, then median is the middle. If it's an even number, then it's the average of the 2 middle. But we rarely do it by hand. Okay, use this to do. Some properties of median. The median does not change if we add extreme value. It is resistant. This is the benefit of median that compared to mean. So we have these two. Look at the two score that we have 2 samples. One sample does not have extreme data. The other sample has an extreme data of 5. And we can run it again. So do I still have one? So one has 5. So let me remove it. Just delete it. And I'm going to evaluate 1 again. Evaluate. So 1 median is 80. Right? It's 80. 2, if I, oh, not 2. Let's just add 5 here. And I evaluate again. You will see that the mean changed to 69.5, but the median is still 78. It doesn't change much. So it is a representative value. It's still right in the middle. So in the case when you have extreme data, a median is a better center. And then mole, I think everybody knows that mole is the value that occurs most frequently. So that means if you look at your data, if a particular value occurred twice or 3 times, then that is the mole. Now for continuous data, you might actually never had a mole because every data may be different. So it can also be calculated for qualitative data. So if your data is not a measurement, but it's just a name, a mole is meaningful, but mean and median is not meaningful. And also you can have multiple moles, but you can see that instead they don't calculate mole for you. They calculate mean, median, and mean range, but there's no mole. So how do I calculate mole? If you want to, you can use, I think I find some, calculator soup can calculate mole for you. They actually show multiple mole. So if you want to, you can do that. Okay. If not, a better way to do is, scan your data sets, but it is hard to scan, right? So normally what we do is you go to data tool, you sort the data. If you sort the data, one column 1, say for example, and I sort it, then they would arrange this from small to large or large to small, and you would be able to scan if there's double. Okay, so this is what we usually do. We have to do it by hand without using the calculator things. But mole is not very commonly used for continuous data because you usually do not have mole. Okay, so the last one is mid-range. We only have mid-range is, how do you calculate them? Is the lowest number plus the highest number divided by 2. So you can say that it is in the middle, but it is not resistant to extreme data. If you have a big data, it would be distorted. So yeah, but it's easy to calculate. So if you're trapped in the island, you can actually calculate. Okay. So that's the 4 measure of center.